Hey everyone! Welcome back to my channel. In today's video, I'll be assembling a complete line following robot kit. Whether you're a beginner or an enthusiast, this kit is designed to get you up and running with minimal effort. Let's take a quick look at what's inside the kit. You'll receive a line follower chassis, a custom-designed PCB carrier board, gear motors, 3D printed wheels with grips, an 8-channel analog IR sensor array, an N20 ball caster, a rechargeable battery with a holder, connection wires, screws, and everything you need to assemble your robot. The kit even includes a pre-loaded operating system with an OLED display and a demo line following code, so you're ready to test and run your robot straight away. If you're interested in purchasing this kit, feel free to message us on our Facebook or Instagram page of Robotech Innovator. If you're new here, don't forget to hit the subscribe button and turn on the notification bell so you never miss any of my upcoming videos. This video is sponsored by JLCPCB. JLCPCB provides easy, affordable, and reliable PCB and PCBA solutions, empowering electronics engineers to develop projects efficiently. For this project, I designed my PCB using EasyEDA and exported the Gerber files. Then, I created a new account on JLCPCB and received a total of $60 as a welcome gift for new users. To place my order, I simply uploaded the Gerber file to their website, selected the quantity and color options, and finalized the order. You can get 5 high-quality PCBs for just $2. What's more impressive is that JLCPCB provides real-time tracking of the entire production process, so you know exactly what stage your order is in. After a few days, the PCBs arrived at my doorstep. Then I assembled the board with the required component. Then I tested PCB and everything worked perfectly. If you're looking for a smooth, affordable, and professional PCB manufacturing experience, JLCPCB is the way to go. Now let's get started with the assembly. For the motors, you can use either N20 gear motors or 16GA gear motors with 600 plus RPM. Both work similarly for this build. First, let me introduce you to the main components on the carrier board. The board measures 7.5 centimeters in length and 6.5 centimeters in width. I've used an Arduino Nano as the microcontroller and a TB6612 FNG motor driver. I have used this driver due to its compactness over L298N. There's also a built-in buck converter module that steps down the voltage to power all 5V components reliably. To handle the IR sensor array, I've included a 16-channel analog multiplexer module, which allows for a clean and expandable design. An I2C compatible OLED display can also be connected for real-time data. Plus, the board is equipped with reverse polarity protection, so even if you accidentally connect the battery the wrong way, your board stays safe. Let's begin assembling. I first mounted both gear motors and the wheels onto the chassis, which measures 16 centimeters long and 13 centimeters wide. Then I attached the IR sensor array to the underside of the chassis, followed by mounting the carrier board in the center. Next, I connected the left and right motors to the carrier board's motor connectors as per the circuit diagram. Since I'm using a 7.4 volt battery but my motors require 12 volt, that's why I added a boost converter to step up the voltage. If you already have a 12 volt battery, you can skip the boost module. I mounted the boost converter to the bottom of the chassis, and connected a T-connector at its input to receive power from the battery. Then, I carefully set the boost converter's output to 12 volt before connecting it to the carrier board. This step is crucial to prevent damage to the motor driver. After voltage adjustment, I connected the boost converter output to the power input terminal of the carrier board. I made a custom jumper wire to link the sensor array to the board. The connection diagram for this is available in the manual linked in the video description. I then attached the battery holder at the back of the robot. Finally fixed the N20 ball caster at the front. Make sure the chassis height is balanced front to back, and maintain a 1 cm gap between the sensor and the ground for accurate line detection. With the hardware complete, I connected the battery to test everything. And yes, it's working perfectly and ready to hit the track. In the next part of the video, I'll explain the code that runs the robot. Until then, make sure to subscribe and press the notification bell to stay updated. Thanks for watching the full video.